Then I will start this session. Welcome to this session on circular economy, methods and tools. My name is Casper Boks. I am a professor at the Norwegian University of Science and Technology, the Department of Design, and I've worked with circular economy in the past 10 years or so, albeit from a more social science perspective and not so much engineering perspective as seems to be the focus in this session. But never mind, I will try to do my best to moderate this session. We'll have 5 presenters, and the format for how to run these sessions, which is chosen by the conference organizers, is that we will run 5 pre-recorded presentations of about 5, 6, 7 minutes each. And after that, we will have a discussion session. And we'll do it like this. We ask the audience to write their questions in the chat. And then me and Ivan, who moderates the session from the organization, will make sure that that all the questions will get asked, and we will try to nicely divide them over the presenters. Hopefully there will be questions for all presenters. That would be nice. Talking about the presentations and the presenters, today we have 5 presentations from 5 presenters, and I'm just checking my list of presenters. First, we'll have a presentation from Pravin Kumar Mallick from the Technical University of Denmark, who will talk about designing a configurator for take-back for circular economy. He is doing an industrial PhD at that university and at Novo Nordisk, which is an industrial partner. So he's an industrial PhD student, and he already has 15 years of experience in the corporate sector. After that, we'll have a short presentation from Hanbing, who is a PhD candidate at the University of Liverpool, and she will talk about methods to forecast numbers of end-of-life vehicles and present us a state-of-the-art report on that. Her research is about optimizing automotive reverse supply chains using artificial intelligence techniques. The third presentation today will be by Gregor Schweitzer, and he will talk about detecting cause-effect relationships in life cycle sustainability assessment based on engineering graph. He is a PhD researcher at Fresenius Medical Care in Germany and has his degrees from the Technical University Darmstadt. The fourth presenter today is Marta Rossi from the University Politecnica delle Marche in Italy, and she's a research fellow in the Design and Methods group of the Department of Industrial Engineering and Mathematical Sciences at that university. Her research is about eco-design and environmental sustainability, and she will talk about closing the loop valorization of industrial waste of composite materials through redesign of products from detached value chains. Last but not least, today we'll have a presentation by Philipp Hesse, who was a research assistant at the Heinz Nixdorf Institute at Paderborn University in Germany. And he will talk about an approach to sustainability-based assessment of solution alternatives in early stages of product engineering. So now you know what you can expect. And I would like to ask Ivan to show us the 5 presentations that were pre-recorded. As said, please write your questions in the chat so we can follow along and make sure that we can moderate a nice discussion afterwards.
Hi everyone, my name is Pravin and I'm really happy to be a part of the design conference. I'm going to talk about how we can approach designing a configurator that can help implement take-back program for end-of-life products in order to close the loop for a circular economy. Of course, it does not need to be elaborated how the current take, make, and dispose based linear economy is proving to be unsustainable. It's leading to many of the crises, like the resource crisis, the waste crisis, and so on. But more importantly, for circular economy to work, take back can play a crucial role. Many studies have shown that even though companies today realize the importance of take back systems, they often face challenges in designing and implementing take back for many reasons, including a lack of knowledge and experience in take back practices and lack of skilled professionals in this field. And that's the reason why we embarked on this project to design a configurator for take back. As a first step, in order to avoid reinventing the wheel, we conducted a systematic literature review, going through journal papers published in the last 10 years in the subjects of take back, reverse logistics, closed loop supply chain, etc. These are all very related concepts. From 742 articles obtained in Scopus, we read through the abstracts to select 116 articles for detailed analysis. These 116 articles covered a wide variety of products in different country settings. As you can see in the graphs, for instance, 18 product categories, highest on waste from electrical and electronic equipments, followed by medicines. Each article covered only certain aspects of take back. We did not find many articles that gives us a holistic perspective needed to design take back configurator, in a way establishing the need for our study. From a content point of view, this study gave us various insights on the who, what, why, how, etc. For instance, fundamentally, why would a firm initiate take back? What are the motivations? Is it compliance or anticipation of regulations or economic reasons? Or is it customer expectations? Or is it just corporate sustainability and enhancing reputation, etc.? Specifically on the how, the study gave some very good insights on activities in take back, the different collection systems, the product recovery options, what goes into the design of a performance management system and choice of key performance indicators, the influence of regulations, for instance, those on extended producer responsibility. And this is one of the major reasons or major factors influencing take back. The consumer behavior and role of incentives. Consumers are the first link in the value chain of a take back program, and therefore their involvement plays a very critical role. And all of these insights helped us develop a framework of the configurator. This framework can be seen as a basic architecture for the design of the configurator, giving us a step-by-step approach to look into the various areas or aspects that need to be thought through for implementing take back, and what are the options in each of these aspects or areas. For instance, before we design the take back channel, we need to start with step one. Understand the product characteristics in terms of the material composition, the dimensions of the product, the residual value, which can help later on to inform should we recycle the collected material or send it for refurbishing, reuse, etc. Understanding the real drivers or reasons for initiating take back can serve as a compass for decision making. In step two, we understand what's the current value chain look like? Where does the material currently go? And who are the stakeholders associated? What is the financial aspect in the current value chain? We then go to step three to design the channel in terms of the activities, the key performance indicators, the stakeholders who will need to be involved, the locations where activities need to be carried out, etc., etc. What we are doing at this stage is to develop a prototype of the configurator or an Excel sheet. As you can see some snapshots of the current version, the intent is to make the configurator modular and following the plan, do, check, act, the PDCA cycle, so that companies can use this configurator at whatever stage of implementation they are in. For example, designing stage or implementing or evaluating or scaling up their take-back programs. We see this project of designing of the configurator as a design task that requires similar systematic approach as designing a product or a system. We therefore intend to follow the design research methodology and run at least 3 cycles of product development and piloting this with the industry and incorporating the feedback in the next version. One of the important aspects that we will need to explore is what IT platform can be used that's fit for purpose. I'll stop here. Thank you for listening.
Hi everyone, I'm Hanbing, a PhD student from the System Realization Laboratory at the University of Liverpool. In today's presentation, I'm going to discuss some findings about forecasting the number of end-of-life vehicles. I'll begin with an introduction to the background, then I'll give you an overview of methodology. After that, I'll move on to 5 research directions in prediction models and influence factors of LV's quantity. And finally, I'll conclude with some contributions. Okay, so first, I'd like to give you a bit of background. The rise of circular economy and the development of Industry 4.0 encourage more scholars to pay attention to the field of the management of LVs. Like this figure, regard to the LVs, we expect that they can be collected by manufacturers. Then the recyclable resources can be remanufactured after the detection and classification, and the harmful compounds are delivered to the waste disposal center. However, in certain developing nations, many LVs tend to flow into illicit markets rather than original equipment manufacturers. For example, in 2020, a total of 3.24 million LVs were discarded in China, yet only 74% were recycled. Hence, to increase the number of recyclables, this paper presents a comprehensive review of LV's quantity forecasting. Now, I'd like to show you the methodology. Based on the background, the following research questions are addressed. The first research question reveals the research methods and their application in LV's number forecasting. We found that the methods in this study can be classified into traditional and intelligent methods, and the traditional methods perform poorly when dealing with nonlinear sequences, while some AI technologies like machine learning and fuzzy logic are rarely utilized. Besides, most scholars tend to use single prediction models. And the second research question summarized the 21 socioeconomic factors that affect prediction results. We discovered that few papers have investigated the interrelationships between these influence factors. Additionally, more social factors such as some economic subsidies and preferential policies are rarely addressed. And then, based on the third research question, we recommend 5 future research directions related to LV's quantity forecasting. Then I'll discuss each research direction further. Due to the nonlinear issues and the uncertainty in LV's quantity, we propose the first gap. More machine learning-based models, such as support vector machine, decision tree, and k-nearest neighbor, should be explored in building LV's quantity forecasting models. And then, to overcome the constraints of each component model and increase forecasting performance, hence we put forward the second gap, which is a hybrid forecasting model integrating linear and nonlinear models should be utilized to enhance the accuracy in forecasting LV's quantity. Additionally, a combination of traditional and intelligent forecasting methods should also be investigated. And next, due to the immaturity of LV's industry and the absence of standard regulation in some countries and areas, there is insufficient data to fit and test a forecasting model. For this reason, we propose the gap 3. For small samples, methods should be further expanded when developing prediction model for the LV's quantity. And next, in order to improve the model's generalization capacity, we bring forward the gap 4. Influence factors related to other end-of-life high-value products need to be referenced, and the dynamic relationship between these influence factors should be investigated. And finally, consumer decision-making on returned LVs should be simulated under various policies. Finally, in conclusion, the forecasting methods for LV's quantity in this paper have been divided into traditional and intelligent methods, and the characters of each forecasting method have been analyzed. Then, influence factors affecting the prediction results were summarized. This paper is thoughtful to be useful as a reference to assist the scholars in creating new research directions connected to LV's quantity forecasting. If you would like more information on this, then please feel free to email me. Thank you for your attention.
Hello and welcome to the presentation of our paper, Detection of Cause-Effect Relationships in Lifecycle Sustainability Assessment based on an Engineering Graph, written by Simon Mörsdorf and Professor Dr. Michele Vielhaber from Saarland University and Dr. Michele Bitzer and myself, Gregor Schweitzer from Fresenius Medical Care. In our paper, we have the objective of supporting lifecycle sustainability assessment by detecting cause-effect relationships automatically. The challenge here is that data from different sources needs to be connected. The data sources can be from engineering, from production, from norms and regulations, and from non-government organizations such as the World Health Organization and the United Nations. All of this data needs to be modeled in one model to represent the complete product life cycle and be leveraged to perform an LCSA. The solution we would like to propose is the engineering graph based on graphical databases those are well suitable to connect data from different sources in one model and therefore can be used to support LCSA in our use case. First, we had a look at the literature of LCSA to find requirements and current challenges. The requirements are that the LCSA shall consider the entire product life cycle as completely as possible, so from raw material extraction until recycling. By doing that, it shall also consider all three pillars of sustainability. Those are the environment, analyzed by life cycle assessment, the social pillar, analyzed by the social life cycle assessment, and the economic pillar, analyzed by life cycle costing. Current challenges are that current approaches do not consider all three pillars. They focus on one or two of them, but not on all of them combined. Additionally, there's a lack of interconnectedness among the pillars. The current approaches focus on the pillars independently, but do not look on interconnections between these pillars. Cause-effect chains and mechanisms leading to an endpoint are not followed in their entirety. And lastly, there's performing LCSA is a high manual effort, and it is subjective in defining the system boundaries and stakeholders, which results in two engineers performing an LCSA on the same product can have different results, and because of the subjective choices they made when performing their analysis, and this leads to the analysis not being comparable and not being consistent. Why do we believe that graphical databases are suitable to address this? Well, they focus on the relationships between data and not on the data itself. They consist of nodes representing entities and lines representing the relationships between these entities. And both nodes and lines can have quantitative and qualitative properties. Yeah. So in the end, it looks like a network, consisting of nodes and lines, and all of these can have properties to traverse them more easily. The advantages are that the schema is not fixed at the creation, and therefore different sources with different schemas can be added later, which is exactly what we need for LCSA. Additionally, we have higher efficiency with data sets that contain many relationships. That is exactly what we need, because we need a database that focuses on the relationship. The data itself is already stored in specialized data sets, but what we need is to focus on the interconnections in order to find the cause-effect relationships that we are looking for. In engineering, the engineering data is created and stored in discipline-specific authoring tools. Those can be for lifecycle assessment, for software engineering, for mechanical engineering, and for electrical engineering. There are methodologies that span these engineering disciplines that are cross-discipline, for example, model-based systems engineering. But model-based systems engineering does not cover the entire product lifecycle from raw material extraction to recycling. That's why we propose to have a cross-company level, the engineering graph, above it, that does span the entire product lifecycle and is able to include company external sources as well. How can the engineering graph look like? In this exemplary picture, we see on the left side the deliverable, that those in the yellow node, those can be the deliverables that are created in the product development process, such as parts, change requests, stuff like that. And on the right-hand side, we see the references. Those can be norms. We see those in the brown nodes. In the upper part, we have the norms that are relevant for the development for medical devices. In the lower part, we see norms that are relevant for LCSA. And through that chain, we see that we can find interconnections between the deliverables created in the product development process and the norms that have different requirements on these deliverables. The engineering graph can also contain LCSA data, and this example, different midpoints and endpoints. These can be leveraged for every LCSA that is performed, so it will be more objective and less subjective. As a further example for data that comes from non-government organizations, we see here that the graph can also contain data from the World Health Organization, such as the health system building blocks. And on the right side, we see the health workforce and the medical products, vaccines, and technologies. And we see that the health workforce is connected to roles, and the medical products, vaccine, and technologies is connected to the outcomes, which is the data from the company. So we see here that the company external data is connected to company internal data, and these connections can be leveraged to detect cause-effect relationships. So in our paper, we had the objective to support lifecycle sustainability assessments by detecting cause-effect relationships automatically. Our solution is the engineering graph that we would like to propose, because it is well suitable, as we have seen, to connect data from different sources in one model and therefore support us in finding cause-effect relationships. Thank you very much.
Good morning, everyone. I am Marta Rossi, a research fellow of Università Politecnica delle Marche. I will present you a paper dealing with the valorization of industrial waste of composite materials and related benefits in terms of environmental performance. The object of the proposed method is to support companies and designers in the evaluation of circular strategies through a structured process which leads them to quantify the environmental benefits of reusing scraps as raw material. The use of composite materials is growing, and a big challenge for this industrial expansion is the development of approaches and technologies to optimize the waste generated from manufacturing operation and end of life of products. The analysis of the literature outlined the need to identify application for the recycling of these materials, facilitate the end-of-life processing, and define guidelines for designers to support them in the optimization of scraps end-of-life. The proposed method foresees at first the analysis of the as-is situation, both for scraps and target products. Target products represent the product or the family of products where scraps could be reused, thus substituting virgin materials. Several parameters need to be defined or quantified: quantity of scraps produced, typology and chemical composition, geometrical properties, features and shapes for components and scraps, disposal scenarios and end-of-life treatments, and environmental impacts related to the involved cycle phases of scraps and target products. At this stage, the evaluation of alternative circular scenarios can start. A to-be scenario foresees the identification of one or more circular strategies to apply for the specific situation. Technical feasibility guide the choice. Then, the evaluation of the to-be scenario by quantifying the environmental benefits obtainable by the implementation of the strategies and evaluating the effort required for design modification of components and their shapes which need to allow the application of the circular scenario identified, and manufacturing operation needed to make the scrap reusable. The environmental benefits of circular strategies need to be verified by the use of quantitative methods and tools like, for instance, life cycle assessment. The proposed method was applied by two Italian companies from the Marche region. One company made its scraps available to be worked and employed as secondary material in the production of a professional coffee grinder. The scraps are derived from the manufacturing of sink for domestic kitchens. The as-is analysis evaluates the environmental burdens through life cycle assessment for scraps and coffee grinder. The results of the environmental analysis, both for scraps and coffee grinder, show several potential improvements can be obtained. First, avoiding incineration or landfilling, and secondly, if the scraps are used in the coffee grinder, it will lower the material phase impact. Thanks to their simple shape, three components of the coffee grinder were identified to be suitable for reusable reuse strategies, but at the end of the evaluation phase, only one is selected as the more suitable, the bell lid. The lid has the function to cover the coffee beans, thus preventing them to be exposed to light, humidity, and dust. The lid, as shown in the figure, had initially a specific shape intended to couple with the bell and stay stable over it. Redesign actions modified its geometry so that neither bending nor material adding processes were needed. Once the remanufacturing process was identified, according to the proposed method, the environmental evaluation of the new scenario allows to assess the benefits. In particular, we can observe a reduction of about 20% of impact if we consider the overall group the lid is part of. Implementation of the methodology identify the first potentiality of establishing relationship among companies acting in different sectors. In particular, some strategies that can facilitate the implementation of circular economy can be identified, and in particular, the simplicity of shapes and the modularity, which can reduce time and cost of modifications while increasing the design flexibility. Future works will consist in integrating also the economic sphere in the analysis in order to include these aspects and to integrate environmental and economic consideration inside the same method. The research work has been realized as part of the project Mallick, which foresees the creation of a research laboratory for innovative composites inside the Marche region.
Hi, I want to talk about an approach of sustainability-based assessment of solution alternatives in early stages of product engineering. My name is Philipp Hesse, and I'm a scientific employee of the Chair of Product Creation at the University of Paderborn in Germany. Our head is Professor Gressler. For this research, we addressed 4 different types of needs, because at first we want to represent the material and information circularity inside an assessment of solution alternatives. Then we want to represent the different stakeholder perspectives of each life phase: strategic planning, engineering, realization, product usage, and end of product life inside in such an assessment. Then we have different evaluation methods, and there are often ethical challenges in the criteria, and we want to address this as well. The main target is that we can identify solution alternatives that are able to raise up the material circulation in the product end of life. So at all addressed products that do not address those things as fixes that fail. Here are the research approach and the systematic approach of this presentation. First, we have the systematic literature review and the fundamentals with some examples, and the assessment in early product engineering phases. And finally, we have the validation. So first, in the systematic literature review, we use keywords like sustainability assessment and evaluation, or assessment and evaluation for solution alternatives, and other keywords. There are some examples. For example, the life cycle assessment, which is a very generic methodology and had to be detailed. As visualization method, Van Hoof presented the integrated sustainable triangle and combined the 3 dimensions, social, economic, and ecological, as a mixing ratio. So let's talk about the approach of sustainability assessment in engineering. This approach is located in the system architecture and the implementation of system elements inside the V model of the VDE 2206. And the result of this assessment are 5 different decoupled sustainability triangles. 1 triangle for each product life phase. Let's jump in. First, we have the solution alternatives, and we assess them by 3 steps: the properties, criteria, and the assessment. And first, with the properties, we generate the relevant properties and the relevant criteria. And in the second step, the criteria were weighted by the different stakeholder perspectives and targets of the product. And the weight criteria are going in the third step to assess the different solution alternatives. The result is added into the decoupled sustainability triangle. So let's talk about the decoupled sustainability triangle. We have the 3 dimensions in each corner, and the value of 1 dimension goes from 0% to up to 100%. And inside we have the continuum, which will be mathematically defined later. This is the calculation method. It is a very vectorial calculation, and each dimension is represented by 1 vector. And in the red circle, you see the intersection point, and we have 3 intersection points of these vectors. The intersection points are used to generate the available triangle, and the geometrical centroid of this triangle is the sustainability of one solution alternative. And by that method, we can decouple the dimension and have no ethnical challenges. By the geometrical centroid, we can define 4 areas: Trinity, where the dimensions are relative equally to each other, and we have the area, for example, weakly social dominance and strongly social dominance, where the dimension social is much higher than the other dimensions. So let's talk about the validation of this approach. We used the brewing unit of a fully automatic coffee machine in the validation, and created some sketches. In an expert interview on the stakeholder perspective of the engineering phase, we generated the values of the dimensions and added them to the sustainability triangle. In the middle, we see the red dot, and the red dot is located in the middle and shows that every dimension, social, ecological, and economical, have nearly the same value. So the brewing unit with the fixed chamber is, in that context, better than with a flexible brewing chamber. If the company wants to address all dimensions in the same, nearly the same value. So the company can decide in which area they want their solution alternatives, and by that they can identify the relevant solution alternative. So let's come to the conclusion. I've presented you the approach of the assessment of solution alternatives in early stages of product engineering, and these models and the reference and the results are presented in the decoupled sustainability triangle, and address the ethnical challenge. For the outlook, it is possible to generate a dynamic continuum inside the triangle, which represents different values of the dimension in another way. And finally, it is possible to integrate the digital twin in this assessment. This has the advantage that the criteria can be defined in a detailed way. These are my references. Thank you for your attention. And if you want to contact us, you can find the relevant data. Thank you.
Well, that completes the 5 presentations that we promised you in this session. And yes, it's a bit an uncommon format for me to have it like this, but I've seen from other sessions that it can work very well, and that it can be a good discussion also because presenters have the option to prepare the questions, which they can read in the chat. So I hope, Pravin, you are the one who got the question in the chat from Giovanni Formentini, and of course it is possible that the ones asking the questions now turn on their video, so we can have a discussion. Probably this is true for others as well. But I can read out the question for you. Giovanni thanks you for your interesting presentation, and he's wondering, how do you compute or evaluate the residual value of the product? And also, where and how are you planning to get data to run the configurator? Please, Pravin, could you answer his questions? And then please unmute, of course.
Yeah, I guess you're muted, Pravin, because I don't know, I cannot hear him. I don't know if anyone can hear him.
No, I cannot hear him either. It's the menu under all the little screens from the presenters. There you find in the middle the button, in case you haven't found it. Tim McAloone, who is your co-author, he suggests refreshing the browser. In the meantime, I would like people in the audience to ask more questions. Maybe we can hop briefly over the question from Giovanni and we'll take that later. And now give Gregor the opportunity to answer a question from Selma Leonardi. Can the tool you present? Yeah,
sorry.
Please.
No. If you want to read the question, sorry, I didn't want to interrupt you.
Well, she asked if the tool that you presented can be used by non-LCSA experts, and what is the basic knowledge one should have to properly understand the identified cause-effect relationship?
Yeah, thank you very much for the question. The tool itself finds relationship and suggests them. So we run machine learning on the existing model, and we find relationships and connected nodes, and based on that we run the model on our graph and get suggestions which nodes should be connected and which nodes are close to each other. And from that, an LCSA expert can validate if these should be, if there is a cause-effect relationship that has been overlooked before, or something unexpected that is close to each other and that has an effect. So we definitely need human knowledge there. We need the expertise to validate what the system has found. Let me read the second part of your question. Basically, that is the answer. So the tool itself is operated and run by somebody who can do the programming and who understands graphical databases. But for the domain knowledge, we definitely need LCSA experts for that use case.
Thank you, Gregor. And I see that Pravin has now unmuted himself. So
yes, sorry
if you're
for
ready.
that. I am certainly ready, and thank you for the great questions. Both the questions, Giovanni, are very, very good. Your first question is around how do you evaluate the residual value of the product? And I think it's one of the fundamental questions when we started to look for designing the configurator, that once you take back the product, what do you do with it? So the one option is the laundry list of different recovery options. And we have the 9 R's there. So you have the upgrade possibility, you have the repair and maintenance, reuse, refurbish, remanufacture, recycle. And we found in the literature decision tree, how do you assess the properties of the product that you have recovered at the end of the life or end of use? Does it have a functional value? Do you still, as a company, do you still sell that product? Does it exist in your catalog? And if so, is there a possibility to upgrade it? So through this decision criteria, a company could come to a decision on whether it makes sense for them to recycle it or refurbish it or remanufacture it, or the other options. Then your second question is around planning to get the data. That's also a very good question. And fortunately, I'm doing an industrial PhD. I work with Novo Nordisk, and we intend to use the configurator for designing take back for disposable medical devices like the insulin pens, etc. And therefore, and we started doing the pilot in Denmark, now in UK, and there are plans to implement this in many other countries, not just in Europe, but also in US and China. So hopefully, through the design research methodology framework, we'll be able to have 3 cycles and we'll get a lot of data on different aspects of the take back, the cost aspect, the incentives that might work in motivating consumers, the recycling technologies, and the value of the different fractions, etc., and what we can do with the different fractions. The literature study definitely gave me a lot of ideas around collection models that exist in different product categories, and I'll be happy to share this later.
Thank you very much. Thank you very much for the detailed answer.
Thank you. Welcome.
Yes. Thank you, Pravin. Maybe you can also take the next question in the chat, which is from Isaac Ortega Alvarado. He wonders how your configurator differs from other expert system templates and what's the advantage.
Thank you, Isaac, for that question. I think it's also a very good one because when we started to look at configurators, we found that information or knowledge exists in bits and pieces. So, collection, how do you get deep into collection models, etc., on performance measurement, but we did not find, and so on and so forth, but we did not find one holistic configurator which could solve your end-to-end questions from understanding the current situation in terms of the product characteristics, the motivation on why you want to do a take back, what does the existing value chain look like, and then finally on how do you design the collection, the recovery option, the key performance indicators, the incentives, the influence of regulations. So that holistic perspective is needed, and that's where we believe that the configurator stands out from the other expert system templates.
Thank you, Pravin, for answering that question.
Thank you.
And I'd like to move on to Philip, the presenter from the last presentation. And Grant McSorley asks you, after complimenting you with a very interesting presentation, could you explain how the scoring for the 3 dimensions was completed and how the scales were defined? I see you are typing. Looks like it from the... You have, Philip, you have understood? Can you raise your thumb? Yeah, okay. You cannot unmute yourself. Maybe also the trick of refreshing your browser will work. Maybe then I can ask a question in between for Hanbing. I was wondering, is your recommendations and your research, is that done in particular in the context of end-of-life vehicles in China? Or is this also aimed at, let's say, for example, the European market? Yes, please.
Thank you for your question. My research is now just related to the data of the Chinese data end-of-life vehicles. Because in China, there are many end-of-life vehicles flow into the black market, so it is necessary to build a prediction model for this research. Maybe in future I can use this model to validate other data. Yeah.
Okay, thank you. Philip, it seems like we have you back now. Can you try to unmute yourself? It still doesn't work? Okay, that is a pity, because then we can't hear your answer, and writing your answer in the chat might not be the most convenient way to continue. I will hop over Isaac's question until you perhaps manage to unmute yourself, and move on to the question from Daniela Pigosso. Also to Hanbing, how does the increase of car sharing systems influence the forecasting of the number of end-of-life vehicles? Maybe another question would first be, is there indeed in China also a similar increase in car sharing systems like we see in Europe? And how does it influence your predictions?
As for the car sharing system, maybe in my research I didn't consider it into my research, I just consider some socio-economic influence factors. But like for the other factors like car sharing system, the government policy, the custom motivation didn't not considered in my research. Maybe in my next stage, I'll build the models for this one by one.
Okay, thank you. Philip, I gave you access to something, it seemed, when the request popped up. Can you try to unmute yourself now? Still not. Okay. Well, in that case, I will move to Isaac's question, which were both to Gregor and Philip. But in this case, then, Gregor can perhaps answer it from his perspective. You seem to be working on similar topics related to visualizing sustainability dilemmas. His question is, how do you avoid dumb situations that are quite serious? I'm not sure that I understand, Gregor, but maybe you understand. Otherwise, we'll ask Isaac to show his face and explain what he asks, what he means by this question. Would you like that?
I agree. I can't. Yes, I can't understand the second part as well, but I can answer to the first part. The solution that I presented is not about visualizing sustainability dilemmas. I think that fits more to Philip's research than mine. We only use graphs as a way
Isaac,
to find relationships.
I know you as a colleague, and you are very intelligent. So this must be a very intelligent question that we are just simply not smart enough to understand. Talking for myself, Gregor, of course. Are you there? And can you perhaps? Yes, I see you on my screen. Can you perhaps explain what you mean by dumbing dumb situations?
Yeah, when I say dumbing down is because I see that these two, in your two projects, what you are proposing, it's in a way to have a decision-making tool that will allow people to take a decision by looking at something visually. So because you presented all these costs and effects, and I think you also mentioned very serious issues, for example, in human rights, that are included there. So I'm wondering if this visualization will just, in a way, dumb down. So it will make it. It will make how to say it in a proper way. It will make it, or a politically correct way. It will make it easier for someone in the management to say, "Oh, I'm doing this because that graphic is showing me that I have to do it like that." So, is there something in your research that will kind of counteract this kind of dumbing down situation? Because these are very serious issues that you are putting together.
I understand what you mean now. Thank you for clarifying. The graphics that I've shown you were that small and dumbed down due to a lack of space on the slide. In the model itself, we have way over 100,000 nodes and over 200,000 relationships currently. So we try to include as much complexity as we can from the real world. And when we run analysis based on the model, then the results are in a more tabular form. And the way that was presented is more to foster understanding. So when we receive relationships for recommendations, for example, the way it looks like is that we have one node, and then we see different nodes that they might be connected to based on the model's results, and a percentage of how likely it is that they are. And then LCSA experts have to have a look at that and validate if this is a valid recommendation from the system or not. So it's more like a support system for humans doing the work. And it is not a nice picture for management to justify doing bad things. Yeah. But to answer your question, we do not have something designed in the model to prevent that explicitly.
Thank you, Gregor. Just asking Philip to try again, perhaps. I also have a question for you, so it would be nice if you could be online and you are online, but somehow it is challenging for you to unmute. That's a pity. Then there was another question from Isaac to Hanbing, actually. We seem to have lost his video, so I'll ask it. Hanbing, in which context will your predictions be used? And maybe more importantly, which goals will it influence? For example, more or less production of certain vehicle categories? Have you, can you reflect over that?
Yeah, thank you for your question. And as for the context, I intend to build the prediction model for forecasting the small sample, like the end-of-life vehicles in some region and the countries. The data related to the end-of-life vehicles may be very poor, and the data can be defined into the small sample of numerical data. And besides, I intend to build this model to predict the quantity for the engineering to build the reverse logistics network. If we can predict the number, we can know the certain quantity of the end-of-life vehicles. Then we can collect it and optimize the efficiency of reverse logistics network, and it can also optimize the whole supply chain and the remanufacturing system. Yeah. And I'm now working on how to integrating the deep learning and example machine-based learners to build this predicted model for forecasting the small sample data. Yeah. And just use the end-of-life vehicles data to validate this research. Thank you.
Okay, thank you. Philip, you have your thumb up. You mean you are? Yes.
Yes.
Maybe something
Test,
happened.
can you hear me?
Yes, we can hear you.
Perfect.
Okay, then let's go back to the first question you had, which was from Grant McSorley. Could you explain how the scoring for the 3 dimensions was completed and how the scales were defined?
Yes, that's a very good question. We have the 3 different dimensions, and for each dimension we find at the beginning of the evaluation different criteria. We sum them up in a list, and for the specific product, product-specific criteria were selected and were weighed by the engineers. So the engineers weighed the criteria, and for that we gained the scoring for the different dimension, and were able to allocate the sustainability inside the decoupled sustainability triangle. Is that the answer for your question?
Well, maybe depending on that, I'm not sure if he's able or here to answer that, but we can maybe move on to another question for you from Jeremy. He says it's a very interesting tool, but what about situations where, for example, a design option gives a big environmental benefit at 0 added cost? This would look very skewed towards environment, but should not be thrown out in favor of ideas that have less environmental benefit at higher cost. How does your tool handle that? Actually, that is actually very similar to my question. It felt like, if I have to choose between my 3 children, it looks who am I going to make most happy? It looks like there's always a compromise to be made. But in some cases, environment and economy, or environment and social, may point the same direction. There could be win-win situations. How does your visual representation represent that? I think it's a very similar question to Jeremy's.
Yes. At first, it's a visualization method and not a tool, also the decoupled sustainability triangle. It shows the values of the 3 dimension to each others. And if we represent every dimension with one criteria, then one criteria have a huge impact, so that the environmental friendly part have a huge impact, and the cost part is very, very low. So that can result in a different perspective to the economy. And the more criteria we integrate in each dimension, the effect of changing one criteria is lower than to use than if you use a low number of criteria.
Okay, thank you very much. Then we have a question for Marta. Marta, we haven't heard you, but Isaac has a question for you. Do you situate your research as part of industrial symbiosis? And in relation to materials in circular economy, how do you evaluate composite materials when considering material downgrading?
Thank you for your question. Yes, our research can be considered as part of an industrial symbiosis case, because of scraps of one industry is used as a raw material by a second company. So we can consider it as an industrial symbiosis. And for what concerns the material degradation, this analysis is included in the technical evaluation made by the company that want to reuse the scraps. At this stage, the company both consider the technical characteristics of the materials in their product, and then compare these characteristics with those of the scraps. And in this case, we have no degradation, because of these scraps are produced by the manufacturing companies of kitchen sinks. So there's no processes or treatment of the scrap, but only some manufacturing processes, like for instance, finishing operation or cutting operation to allow the scraps can be used in the second product. So in this case, there's no treatment. But of course, when we talk about scrap treatment, we need to consider this degradation of properties, and we can consider this in the technical feasibility evaluation that we have included in our approach. Thank you.
Thank you, Marta. Maybe I can ask you a follow-up question. Do you think, how do you see, let's say, the tool be implemented? Is it the responsibility of the suppliers of scrap to find, let's say, a destination for the scrap materials, or do you see the, let's say, the equipment or the product designers, is it their responsible to find data from the scrap, or is it more some holistic municipal governmental body who would, let's say, run this tool and bring these parties together? So who is the intended audience, or is it just an academic exercise?
Of course, at the moment, there's no legislation or regulation that obliges the companies to consider for the scraps some circular strategies. So at the moment, it's an academic exercise, but companies are awareness that in the next future they will probably become more and more responsible for the scraps. So inside the Marlick project, in which this research is included, companies try to solve in advance problems related to their scraps in order to are able to answer in the best way to possible legislations that can be regard their manufacturing activities.
Okay, thank you. That is very clear. As far as I can see, no questions asked in the chat remain unanswered. So I'd like to ask anybody in the audience, or maybe the presenters themselves, if there's any question to be asked. Then here's some from Tim McAloone. Question for Gregor and Philip. To what extent are you not just verifying, but also validating your modeling tools? In other words, when do we know how effective they are in helping to make the right decisions? Perhaps usability comes before usefulness, but maybe you can share an idea of the time plan, because I'm sure you will be interested in the usefulness as well. So it's a very valid question, of course. Gregor, you are nodding. Perhaps you can shed your light on this question.
Yeah, thank you very much. That's a really important factor to validate if it's actually useful. And we plan on working on that and actually using it when performing an LCSA and seeing how helpful it is. But of course, it is very hard to measure. Like, what do we measure? Quality, that's very subjective. If we measure speed, that's also hard to compare performing LCSA for different products, and then it's not comparable anymore. So it's kind of not trivial to validate. But of course, we will use it and maybe do some qualitative research and get comments from the people who actually used it and do use that as validation. Yes, I hope that answers your question.
What about you, Philip? Could you?
Yes, I can unmute myself. We will use this visualization method in a project where we lay down the focus on the additive manufacturing process, and in the design phase where we define the different shapes and geometries of the product. It is possible to get a feeling that the engineer get a feeling about the representation of the dimension with its generated shape and geometries, because of the huge number of criteria and huge number of for example, design nodes and their dependencies to the dimensions. It is very, very difficult to get a feeling what kind of parameter would influence in a dimension. And with this visualization method, the engineer had the ability to get a feeling about this product in the design phase. And we will validate this in this project and the additive manufacturing process.
Okay. Thank you very much. Then this is the last moment to raise your voice, your hand, or write something in the chat. But if there are no more questions, I would like to thank all the presenters for nice videos and good questions, good answering of questions. And of course, I would like the audience to thank the audience for attending and asking questions. I think we had some good points raised, and I hope this will help the presenters to continue with their research. I would like to point out that there is another session on circular economy, if I'm not wrong, very soon. And then I think I will close this session again. And I wish you all a very nice day and a very nice rest of the conference.
Thank you very much. And thanks, Tim, for your last message.
Yes, well, this is some possible validation considerations for Philip Gregor. Please take them with you in your research. And again, have a nice day, everyone. Thank you for attending. Bye-bye.
Bye-bye.
Thank you. Bye-bye.